Hello chaps and chapettes, and now we're going to be continuing looking at ionizing radiation with the beta particle. And by the end of this video you should know what one is and understand the properties of a beta particle. You should also be able to describe how you detect one, similar to how we did with the alpha particle. Now the challenge today is to do a little bit of alchemy, and we can do something as physicists which chemistry and alchemy has been trying to do for centuries and couldn't manage. So what you're going to do is you're going to turn lead into gold using only alpha and beta decay. So let's have a look at what beta decay is, and we'll have a bit of a discussion about how you could do that. So what is a beta particle? Well, a beta particle is a high-speed electron or a high-energy electron, and this can be shot out from a nucleus. Don't get confused with the electron zipping around the orbit of an atom. This is a different one. Now you might be asking, well, why do you have an electron coming out of the nucleus of this thing? Well, what happens is this. A neutron is going to decay into an electron and a proton. Now you can imagine that a neutron being, well, neutral charge, it essentially has the charge of a proton and the charge of an electron fused together within itself. And that's generally how it really is. At the very beginning of the universe, you had hydrogen particles bouncing around, which are just protons and electrons. And at some point, there was enough pressure and enough energy to get these things to squeeze together into the first neutrons. And there you go. These things aren't stable though. Neutrons are not stable. They will decay out into protons and electrons. Now, in the picture in front of you, you've also got this funny little V symbol there. Don't worry about that. That thing is called a neutrino, and it's just there to solve some interesting energy problems we've got with the whole decay process, and is beyond the scope of GCSE, so don't worry about it. What you need to know about the beta particle though is it's got a medium speed, which means it's fairly zippy, but it's not going to be as fast as the other type of ionizing radiation you need to know about. It is averagely ionizing, and it is moderately penetrating. It is very much the middle grade student of the ionizing radiations, which can actually make it slightly more dangerous than alpha particles. I mean, it's going to pass through air quite easily. It's going to reach you from a source that is relatively close by. What it does to you though, you'd need quite a high intensity of beam to get that going, but it will eventually reach you. So stop the video, draw the diagrams and write down the properties of the beta particle, and we'll go from there. So now we're looking at the beta particle source instead of the alpha particle one, and the setup is largely the same. If you have a beta particle there, beta particle source there, it's going to start kicking out beta particles towards your detector, and you're going to move the detector away, and you're still going to get relative counts, so you know that you don't have any alpha particles. You want to be sure, of course, so you put a bit of paper in there, but the beta particles pass straight through that paper. So then what can you add? Well, this is what you can add. Another barrier. And that's going to be some aluminium. And the beta particles will be stopped by the aluminium. And that's pretty much how you do it. So there's a couple of ways, there's a couple of things you should know about this. When you are getting beta particles or alpha particles coming out of the source, then actually you are changing the very elements that are here. There's some cool little nuclear equations which we've done already, which you can look up on the quick tips playlists, which show you how the elements are actually going to change when you take these chunks of stuff out of your nucleus. With the alpha particles, it's straightforward. You're literally taking out two protons, which is going to knock down the atomic number to something else. And with the beta particles, you are not necessarily changing anything inside. I mean, well, you are, but you're not changing the atomic mass. But what you are doing is taking a neutron and turning it into a proton, which is going to change the atomic number and therefore change the actual element itself, which is kind of a big deal. So there you go. This is how you can detect a beta particle. Stick some aluminium in the way. If it blocks it, it's a beta particle. And well, there you go. Okay, so by now you should know what a beta particle is and understand the properties of the beta particle. You should also be able to describe how you detect one using a very similar method to what we did with the alpha particle, as we just did. And what you need to do right now is stop the video, describe how you would identify a beta particle, and make sure that's secure in your head. The challenge today is to talk about how you can turn lead into gold. And okay, you can do it. You probably wouldn't want to though, but I look forward to seeing what your thoughts are in the comments below. If you have any questions about these things, please do write them down in the comments so that I can respond to them. It's the fastest way I get any feedback. So I'll catch you in the next video, guys. Remember to like, comment, and subscribe.